to marketing people into your company, or if you want to review the different slides. Okay. Thank you for skipping the slide, Anne. So a quick overview of what we are going to see today. We will, in fact, discuss to master the revised standards 14,500 and 14,501. We will introduce these changes in the first part, and then in the second part, we will talk a little bit more about ESDA, the European Solar Shading Database. What are the benefits? What is the benefits of validation of your data? How can you use it? And then in the third part, we will speak a little bit about ongoing projects for ESO. And then at the end, that will be around 10:30, a little bit more, a little bit before, we will have the question and answers. So the objectives of this meeting today is an introduction to important changes of these standards, which standards we will see in more detail afterwards. Why is this important? It is important because all shading manufacturers need to adapt their product sheets. Until now, we had a lot of product data into different collections, into different product sheets from manufacturers. And in fact, they were not always made in the same way. So we were not speaking with one voice. If we manage to apply these new standards into our product sheets and data from collections, it will be very important because it will allow us all as an industry to speak one language, and this is very important for the communication of the advantages of our solar shading solutions. So we will also share this way the status of key projects for our industry, because that's a very important part. We start really to become very communicative, and we have done a lot of studies. The key point is that we have all the values to make buildings more resilient to climate change. We have an enormous tailwind with us, climate change, the Green Deal from the European Commission, and we have all the natural solutions. So that's why it's so important that we talk with one voice and that we communicate all together in the same way. And the purpose of this meeting is also to try and explain to you so that it becomes clear and that we are able, all as an industry, to talk as one community and to become an essential building technology. That's what we are aiming for. Thank you, Anne.
Now it's turn to Hervé Lamy. Hervé?
Hello, everyone. So my name is Hervé Lamy, and I chair the ESO Technical Committee. So as an introduction, just to a short reminder about the set of standards which apply to blinds and shutters. I guess you all know the product standard, the three main product standards which apply to your products. The EN 13659 on shutters and external venetian blinds, the EN 13561 on external blinds and awnings, and the EN 13120 on internal blinds. These standards refer to other supporting standards which address some specific criteria and specific characteristics. Today we will focus on the two standards dealing with solar and visual properties, which are 14501, which is giving the classification of the products on some characteristics that we will detail, and the EN 14500, which gives the measurements or the calculation methods which needs to be used to evaluate these solar and visual properties. Next slide, please, Anne. Okay.
Sensitive.
So EN 14501 and EN 14500, probably you already know them. They have been published the first time, I think it was in 2006 or 5. And they are dealing with two main criteria: visual comfort, so glare control, view to the outside, daylight utilization, night privacy, and darkening performance, which we were called blackout demode. So we will detail that later on. And on the other hand, the thermal comfort, so the GTOT value, the total solar energy transmittance, which is the official name for the solar factor, the secondary heat gains, and the protection from direct transmission. Today, we will not detail all these criteria, but we will only address the main changes that have been applied during the last revision of this standard. Next slide, please. We will also speak a little bit on these two calculation standards, the ISO 50022-1 and -3. These are the main, the most important standards for our products. They are giving the calculation method of the solar factor and the light transmittance of a shading combined to a glazing. The part 1 is a simplified method, and the part 3 is a detailed method. And we will see that probably in the next years we will make a move to this detailed calculation method, which is more accurate and will be probably a key reference for the industry. We will detail that later on. To detail the four main areas of change that we will speak about today, on the 14500, I will just make a very short introduction about the new methodology, which we have implemented into the standards. And in 14501, we will detail the new classification for glare control, the new classification for the darkening properties, and we will also speak about the new reference glazing we have implemented into the standard. So this is just for you to know that even if you may have a look on the complete standard, really, if you want to analyze what are the changes that have been applied in this standard, you should really address 4 issues if you want to save time and to go directly to the most important part of the standards. Next, please. No, this. Okay, so a very quick word on the 14500, which is giving the calculation and the measurement method for our products. You know that the starting point to calculate and evaluate the performance of a shading is to measure the intrinsic properties of the material which is used in the shading, whether it is a fabric or a slat for Venetian blinds, for example. This measurement is defined by the 14500 and is basically done with a spectrophotometer. It's a standard way of measuring this kind of material. What we have identified when we started the work on these two standards is that for some specific sample of shading material, we had an important, how to say, differences in the results provided by labs carry on that carry out the measurements. What you have on your screen, the graph you have on your screen, is the measurement of exactly the same sample made by different laboratories. So you see that you have these 10 curves almost, and you see that for exactly the same sample, the values, here it is the diffuse transmittance, range from 0.15 to 0.65, which so it shows that when you take exactly the same material, depending on the way the laboratory is carrying out the measurement, you may have huge differences in the results. So when we figured out this in the group, we were first very concerned about the fact that maybe all the measurements that we have done for the last 10 or 15 years were wrong, because as you can see, it's difficult to trust exactly what the labs have done. So we worked for maybe almost two years with our colleagues with Fraunhofer and ITV in Germany. And finally, we have found a way to solve this issue. If you can switch to the next slide. In fact, these differences in the results were really related to some specific samples and to specific material, especially fabrics, for which the way the light or the radiation was transmitted by the fabric led to this problem of measurement. So our target was really not to remeasure everything, because on some of these samples, the majority have been properly measured. But the challenge was to find a way to identify what were these fabrics for which we may have a problem and we may have a mistake in the measurement. So I will not detail that. It's really something that should be addressed by your lab if you have some labs in your company, or the labs that you used for to measure your sample. But just to keep in mind that with the graph you see on the right-hand side, we have identified a way to identify these critical samples, and only these critical samples should be measured in a specific way. It could be a little bit longer, but it can be done with a standard material. You don't need to have a specific material to do this measurement. It's only a new process to evaluate this material. So to summarize this, I would say finally we have found a way, and we can guarantee that whatever the sample to be measured, we will have accurate values which will be provided by the labs. This is very important, and there is no doubt in the values which will be provided thanks to this methodology. If you have any question on that, you can ask. I guess you use some labs in Europe to do the measurement, or you can ask your fabric manufacturers or suppliers, whatever. He should be able to tell you whether these samples that you use is critical or not, and how it has been measured. I will not detail more this issue because it's very, very technical and it's not the topic for today. So I will switch to the next slide. So today we will really focus on 14501, which gives the classification for the main solar and visual criteria. We will deal today with the glare control. Here also we have improved the way glare control is addressed for shading products. To make this will be detailed by Anne van Neer later on, but as a summary, finally the classification is really based on a scientific approach, which was not the case with the previous version. It was mainly based on our experience. Now we have carried out a real study. We have carried out a lot of calculation to define this classification for glare on products. So it's very important. The classification is robust and is on a scientific basis. The second goal was also to create a link with the EN 17037, daylight in buildings, which is standard. Sorry, I have a...
Can we ask everyone to close their microphones, please?
So the EN 17037 is dealing with daylight in complete buildings. So it's not specific to shading, but it creates a link to the 14501 classification for glare. And as this EN 17037 is really targeting architects, it gives a good way to promote shading to these architects. The second item we will detail is about darkening properties. Here also we had some issues with the classification. First, because there was a misunderstanding in the classification where when we spoke about demote and blackout products, it was not really clear whether we were speaking about the fabric material, so the fabric, for example, or the complete product. Here we have two different classifications, one for the shading material and another one for the complete product. You will see, I think it's Maria who will detail this part. You will see that we have really two different sets of classification, and now the idea for you will be to ask your customer which class they want to have. Also, the mistake was that some people claim to have a blackout product, but in fact it was only a blackout fabric. And then at the end, the user or the customer was disappointed. So this will be detailed also by Maria. And we also improved the evaluation of the performance on this topic. And finally, we have also, I guess you all know that we are using standard glazing to give the value of the solar factor and the light transmittance. These standard glazing are defined in 14501. And up to now, we only had glazing for which we had only the integrated values, and now we have a much more detailed approach, and we have the detailed values of the glazing, which allows us to do a detailed classification and a calculation, and something much more accurate. And we have also added a triple glazing as a reference product. So we will detail this in the next minutes. I will now, I think, give the word to Anne van Neer.
Okay, thank you, Hervé. Hi, everyone. I'm Anne van Neer from Helioscreen. I am member of the SO Technical Committee and also of the Training Committee. So this picture shows what can happen when there's no solar shading. It's hard to imagine that this person is comfortable, even if this room is air conditioned. So one of the important aspects of solar shading next to thermal comfort is indeed glare control, making sure the bright sunlight is filtered so it does not cause annoying reflections on computer screens and furniture. And as Hervé said, it is classified by the European standard EN 14501. So the old table of 2005 here on the left was based on industry experience, like Hervé said. So we know that the smaller the openness factor, the less direct light is let through, and the darker the color, the less diffuse light. And the combination of both is ideal for glare. So when you use this table, you could see that a dark colored fabric with an openness factor of 5% was a good solution, and the white color with an openness factor of 10% was not very good. The highest class possible for a fabric with holes was class 3, a good effect. And to have a class 4, you needed a darkening fabric. However, it turned out that even with class 3 fabrics, people experienced discomfort. They started asking for smaller openness factors like 3% or 1%. Yet, if you look at this old table, it seemed that there was no difference between 1%, 3%, or 5%. They all had class 3. And as you can see now in the new table of 2021, it is much more detailed and the table has much more and smaller thresholds. So how did we get from the left table to the right table? Next slide, please, Anne. So like Hervé said, there is a link with this, the new standard for daylight in buildings, EN 17037. And for that, an elaborate study was carried out by several European research institutions to try and predict when people experience discomfort glare. Because this type of glare largely depends on individual factors, this is rather hard to do. As you can see in the picture on the left, they built rotating offices where people were asked to perform tasks on a computer. The amount of glazing could be altered, just like the type of shading. And the person could be either placed parallel or diagonal to the window. The offices could also be rotated to show the effect of the position of the sun. Then from the results of the study, an indicator was developed called DGP, Daylight Glare Probability. So if the DGP is below 35%, glare is seen as mostly imperceptible. But if it is above 40%, it is seen as disturbing. So next slide, please, Anne. So as you've heard, I said discomfort glare. In fact, we distinguish several kinds of glare. In general, glare is the condition of vision in which there is discomfort or a reduction in the ability to see details or objects. But then you have glare causing eye problems. So, for example, when you stare directly at the sun for too long, the radiation can damage your eyes. So that is why we have solar viewers to look at the sun during an eclipse. Then you have disability glare. And then you really cannot see objects because there is an intense light source in your field of view. For example, when the headlights of an oncoming car blind you. And then finally, discomfort glare is the annoyance or pain induced by overly bright sources. You still see things, but because of this glare type, you have trouble concentrating and may get a headache. And because the amount of discomfort differs from one individual to another, it is also named psychological glare. Next slide, please, Anne. So now what is the definition of glare control? It is the ability of a solar shading to control the brightness of windows and to reduce contrast between different areas in your field of view. The people in this picture can work on their computer comfortably because there is an effective solar shading present. Next slide, please, Anne. Next. Okay. So now how do we define glare control? As I said earlier, it's a function of the direct light transmittance. That is a transmittance through the openings of the solar shading, and of the diffuse light transmittance, which goes through the material itself. Together, they make up the total light transmittance, as you can see here in this picture. Next slide, please, Anne. So here we have the new table, and you can see that the levels of diffuse and direct light transmittance should, so you can see what level of direct and diffuse light transmittance you should have to get a certain class. And this table is entirely based on the study that I just mentioned about DGP. But you have to take into account that it is still a simplification of reality. The goal of this table is to be able to compare different materials to each other when other factors are still unknown. In reality, you will also have to take into account some other aspects like the location of the building, the orientation of the facade, the amount of glazing, the type of glazing, and also the viewing direction, parallel, perpendicular, or diagonal to the window. And to help you with that, you can find some enlightening tables in the annexes of EN 14501 and also in the Daylight in Building standards. So this table for classification was actually based on the situation for Frankfurt am Main in Germany. It is for a south-facing window that is glazed for 50% to 100%, and the viewer is seated parallel to the window at a 2-meter distance. So that is a bit of a general case that was taken to make the table. And as you can see here, that is very different to the previous one, that a direct light transmittance of more than 3% is already too high to have a good glare control class. If you know that 3% is good, class 3 is good. And also the threshold for direct light are much smaller. You only go 1% at a time. So that makes that an accurate measurement of the data is critical. So in any case, you can keep using the data for light transmittance you have measured in the past, but it's just the classification that has changed. But that's not the only thing that's new. If you look at the highlighted area, here it is possible to gain a class if you can justify a cutoff angle of less than or equal to 65 degrees. And how you have to measure this cutoff angle is described in EN 14500. Next slide, please, Anne. So I think that for most people, this word cutoff angle is quite new. So the cutoff angle is the first angle of incidence at which the direct light transmittance is no longer perceivable. So it actually describes the ability of a solar shading device to block the transmission of direct light above a certain angle of the sun's rays. So in the drawing is an example of a fabric with holes. So in the left, we have a thin fabric. And as you can see, the sun rays will go through at almost any angle, except maybe the highest ones. But if you have a thicker fabric, then you can see that the angle at which the light is cut off is much sharper. So there you would be able to have this extra class for glare control. At the moment, I do not think that there are many fabrics that really qualify for this. But of course, by including it, maybe it can inspire new developments for solar shading devices. We have some advice from the Daylight in Building Standard EN 17037 Annex E, where you can see that there is a difference between opaque and open materials. So for opaque materials, low values of daylight glare probability can be achieved when people can operate the device, and when you cannot see the sun when the solar shading is fully extended and closed. An example are Venetian blinds, but they will only fulfill the conditions if the holes of the inner cords are hidden. That's very important, and that there is no reflection on the slats when they are closed. Also, there can be no direct view of the sun through any gaps. And then, of course, for fabric films and other perforated materials, it's a bit different. There, again, you have the visual properties. That's actually what is in the table we described. So you have to look at the direct and diffuse light transmittance and also at the cutoff angle. And then, like I said, there are some other important aspects that you have to take into account: the location of the building and how often the sun shines in that location. So the viewing direction, am I looking directly at the window or am I at another angle? There's the orientation of the facade. Is it directed to the north, the south, the east, the west? That can make a huge difference. Also the amount of glazing in the facade, how big the windows are. And there's, of course, the transmittance of the glazing itself. What color is the glazing? What type of glazing is it? And then also the distance of the user to the facade. So to the window, if he's closer, of course, he will experience glare sooner than when he is further away. So that's it for me. I hope everything is clear. And should you have any questions, you can put them in the chat and then we will have a look at them later on. So I now give the word to my colleague Maria Moya to tell you about the darkening properties.
Hello, thank you, Anne. This is Maria Moya. So I work in training, and also I work in doing research with the technical committee. And we both, Anne and I, are members of the standardization of the European Standardization Committee. So darkening performance is the capacity of a blind or a shutter when it's fully extended and closed to prevent light penetration. And now, Anne, if you click twice, because this light penetration can be in a regular form in the whole area of material in this case, or through bars or stripes, or also through pinholes, or as we will see later, through the gaps in a solar shading device. So you can move to the next one. The first change, as Hervé said, is in the measurement method. So we use the same method to measure the darkening performance of a complete shading device or a complete blind and the opacity of curtain materials. We use different words here. And for the level of accuracy of this standard, it's been seen that the human eye is sensitive enough to perform the test. And no other electronic device has proven to perform better than the human eye, except a photon counter, which is a perhaps too sophisticated device for our purposes. So the method consists in an observer placed in a light-tight environment. In this drawing is this area number 2, which is gray. And he shall detect if light is perceptible through a material or a blind when it is illuminated on the other surface. The illumination area where the incident light is area number 1 on the right on this drawing, and the material of the blind is placed at number 3. For some classes, then an additional light source, number 4 in the drawing, is employed. And this very low level of light, 2 millilux, wants to represent or simulate the effect of a real situation, such as having an alarm clock inside the room at night or some light passing under a door. The light levels, all the light levels of the incident light or this small light are measured with a lux meter. So you can move to the next one, please. The minimum dimensions of the samples to use is for materials such as fabrics or slats. The minimum size is 20 centimeters by 20 centimeters approximately. And for complete products, for blinds, it's 1 meter by 1 meter. The materials shall be mounted in a way to prevent light coming through the edges that may disturb the results. And the sample to measure, it is not necessary to measure all samples of all materials, but the samples to measure needs to be representative of the most unfavorable situation. And the products, the blinds, are mounted in accordance with the instructions of the manufacturers. Also, the distance between the eyes of the observer and the sample to measure are established, and they depend on the size of the sample. You can see on the right that the light level, the color rendering index, needs to be high, above 0.9, because the incident light needs to mimic the spectrum of the solar radiation. And also the uniformity of the incoming light needs to be relatively independent or quite uniform, depending on the angle. Which is very important for this method, is that the observer needs to be qualified before the test. Not all observers may be qualified for this test. And for this qualification, a reference curtain material, such as a master, so to say, a master sample, is illuminated at the level stated for this specific curtain material. And the observer in the room, which is in the light-tight environment, needs to perceive light within 15 minutes. If he can perceive sunlight after this period of adaptation to the darkness, then the observer and the room are validated. And then the real test with the material or the product can start. So next one, please. When the material or the shading device is measured, if no light is perceptible for the level of illuminance selected, the corresponding class, according to EN 14501, what we will see later, is achieved. And 2 observers are qualified before the test. So the test is repeated with a second observer. If there is a discrepancy, if one observer sees some lights, let's say under 30,000 lux, and the second one doesn't, so the test needs to be repeated with a third observer. In these images, you see some examples of simple rooms that can be used to make these observations. In that case, because of the size, you see, is to be used with material, with fabrics or slat materials. So next one, please. So now that we have the new methodology to measure the darkening performance of solar protection device according to 14500, we are going to talk about the changes in the classification of this performance that are established in 14541. So this is the previous classification you may well know. For a material to be considered blackout, no light should be perceived when tested under 100,000 lux. And then there was a second class to classify a material as dim out when it used only 1,000 lux. So there was a large gap between these 1,000 lux and 100,000 lux, which was too strict for most materials. And more or less for the opacity control of products, it was said, the same basis was employed. In that case, 75,000 lux. So if you can click 3 times on, yes. So in the new standard, the terminology blackout and dim out is not used anymore. And instead, some classes, as we have in other performance characteristics, have been established. So you can move now. Let's start with curtain materials, such as fabrics or slats. The opacity, now we talk about opacity performance of materials, is the capacity of this material to prevent the light penetration when tested under different levels of illuminance in lux. As you can see, 5 classes have been established, and the brighter the external light used, it can prevent from penetrating, then the higher the class. So now the equivalent to the old blackout classification now is class 4. It is tested with no internal incident light. This very small incident light in the observer's room, simulating the alarm clock or so. For the other classes, for classes 0 to 3, this small light level in the dark room is used. There is a class 3 now, when no light is perceived under or above 30,000 lux. But if you click on, this is a situation that used to be very common. A blind, a Parisian blind on the left, or a Aurora blind, using a blackout, a very opaque material, but if the blind did not have any light exclusion system or didn't close perfectly the slats, then a high level of light could be perceived. So the complete product would not have good classification of darkening performance. And this is the reason, next one please. This is the reason that classes also for solar protection devices for the complete blind have been established. So now we have numbers 0 to 4 to classify the opacity performance of the material, and letters A to E to classify the darkening performance of the complete device. We need to know first the opacity of the material, and then it is very important the frame of if the complete product has a light exclusion system or not. So if the complete product has not any light exclusion system, then the product is directly classified as class E and not as this carried out. In spite of the fact, for example, to be using a very opaque material. To achieve, if you see in the table, to achieve a class A, only materials classified with class 4 can be employed. But this classification, A4, is intended for very, very specific situation, like specific laboratories, or to work with photosensitive material. For the most common situation, a class B can be achieved when testing the product under 30,000 lux if they use material classified with class 3 or class 4, and in this case, if the product has a light exclusion system, it is tested with this small light level in the observer's area. And I think this is all from my side. If you have any questions, please let us know. Thank you.
I will detail a little bit also the spectral glazing that we have integrated into the standards, and just to explain you in a simple term why did we need this spectral element. Next slide, please. Yes, thank you. So you should know that the performance of a shading can be separated in different sections depending on the wavelength of the irradiation. On the left-hand side, you see that you have the complete solar spectrum. You see that you have some performance related to the what we call the large infrared. So we speak about the emissivity, we speak about the infrared transmittance, and so on. This is a part of the spectrum. Then we have the solar element from 250 to 2500 nanometer. So it's the solar transmittance tau E and the solar reflectance rho E. And inside this, we have also the visual part of the spectrum, which range from 380 nanometers to 780 nanometers, and in which we have the visual transmittance, the diffuse transmittance, and the visual reflectance. So, in fact, the global performance of a shading and on any material is not a complete number. It can be divided in different terms, which address different characteristics, whether we speak about the visual part, the solar part, or the heat transmittance. To calculate these detailed characteristics, we need the intrinsic performance or properties of the material, as I said at the very beginning. On the right-hand side, you see the measurement of a fabric. You have in blue the hemispherical transmittance, which is the addition of the normal transmittance and the diffuse transmittance. And in red, you have the normal transmittance. So basically what the radiation which passes through the holes of the fabric. And you see that for the diffuse or the hemispherical transmittance, the performance varies depending on the wavelength. So if you take the hemispherical transmittance at 1000 nanometers, it will be very different than the one you can consider at 2000 nanometers. And it is exactly what the detailed calculation method aims to do. It really aims to consider in detail all these different characteristics when you consider these different parts of the spectrum. Next slide, please. You have on the left-hand side, so here you have the three main properties that, when combined, gives the solar factor of the shading with the glazing. In fact, probably you are used to have a single value for the solar factor. You have a solar factor of 0.10, 0.15, and so on and so on. But in reality, this solar factor is the sum of different parameters which address different physical properties of the shading. On the left-hand side, you have the first main characteristics, which is the solar radiation transfer, or what we call the solar transmittance. If you consider an external incident radiation, you see that this radiation, the solar ray, I would say, will impact the solar protection of the solar shading when it is external, as it is in the drawing. This radiation will be partially reflected outside, partially transmitted inside. And then this radiation will then transfer through the air gap, and then it will impact the first pane of the double glazing. And again, a part will be reflected to the outside and another part will be transmitted, and so on and so on. So then it passes through the gas of the double glazing, and it impacts the last pane of the double glazing, and a part is transmitted and reflected. And in fact, this solar or radiation transfer on this solar transmittance gives the value of what is the remaining solar radiation, which finally reach the room. So you see, you have a multiple transmittance and reflectance through these different materials, and finally the last value, the remaining part, is the direct transmittance, which we call TOE, solar transmittance. This is the first sub-element of the solar factor, which is probably one of the main. And then you have the heat transfer. Here we are in the long infrared part of the spectrum, and here it's only how the heat passes through the different layers. So the shading, the air gap, the first pane, the air gap or the argon gap of the glazing, and the second pane, and so on and so on. And here again, it's a question of multiple transmittance of this heat through the different layers. And finally, we have into the room two main factors. One is the thermal radiation factor. So what is the heat transmitted through all these different layers? And we have also an additional factor called the convection factor, which is in fact, as the last pane of the glass will be heated by the heat, you will have a convection factor with the air inside of the room, which will increase the temperature of the room by convection. So we have these two factors, the thermal radiation factor and the convection factor, which, when they are additioned, makes the heat transfer factor of the solar factor. And finally, when we have an internal blind, you all know that the hair which passes between the double glazing and the internal blind is cold on the bottom and becomes heated when moving through the hair gap, and then it is hot at the top. This is what we call the stack effect. I think you all know that. And we need to characterize this stack effect to have an accurate approximation of the complete solar factor value. And the solar factor, in fact, is the addition of these four criteria, physical criteria. So it's not only a single value. This single value can be divided in all these different factors. But the thing is that to calculate that, we need to have all the detailed, thank you, Anne, we need to have all the detailed values for each wavelength. As I explained on the previous slide, the properties of these transmittance and reflectance of each material depends on the wavelengths. And so we need to have all these transmittance and reflectance value for each wavelength. This is what we called the spectral values. And this is what we need to calculate, to use the detailed calculation method, which is now defined in the EN 52022-3. And in the standard, in the 14501, we used, sorry, and can you stay on the previous slide? We didn't have the reference glazing with the spectral values. So what we did in the revision of the standard is that we have added three new reference glazing for which we have all these spectral values. We have a double low E glazing, we have a solar control glazing, and we have a triple glazing, which was missing in the first version of the standard. And thanks to these reference values, you are now able to use this reference glazing to calculate the properties of your product, and you can also, the complete industry can use the same reference to provide their properties. And this is important because, of course, the solar factor of a shading depends on the glazing. So if everyone is using another different glazings, then you are unable to compare the different properties of the different shading. So here, the idea is to have reference glazing so that the industry is able to calculate their own products and to compare them to other manufacturers. But next slide, please. What is important to consider now? Yes, thank you. Using this detailed calculation method is up to now quite complex. You need now, sorry, Anne, can you come back? Thank you. It's quite complex. We need to have a calculation software. Probably you know SBO or some other calculation software, and you need all these detailed values and spectral values. When we revised the standard, we considered it was maybe too early to use only the detailed calculation method, and that for the declaration of performance of products, which could be integrated into the CE marking, it was still needed to make a reference to the simplified method that you can use only by calculating on a paper and so on. It's very simple. So it's important to know that when you will do a declaration of performance, you still need to use the simplified method. And when you want to have a more detailed approach, or when you know that exactly the project and the properties of the glazing, you should use the detailed calculation method, which is much more accurate. So basically, just to summarize, we are more or less between on a kind of transition for now. The detailed method is by far the most accurate method, but as it is too complex, we thought that for the industry it is probably too early to have only this method as a reference. So you must still use the simplified method when you just make a declaration of performance. Next slide, please. Okay, this is another idea, but related to the what I said. Sorry, I have an echo. If you can switch off your microphone, thank you. The performance of a shading, we see that sometimes the industry can claim some energy savings and so on, and maybe comparing some products with the other. It's important to consider that the performance of a shading on a complete building is also really dependent on the building properties. It's not only the glazing or the shading or few elements. It's hundreds of elements which needs to be considered. To illustrate that fact, you have here some calculations we did on the cooling energy on a very simple building. It's a kind of a shoebox with one single window. On the left-hand side, and the difference between the left-hand side and the right-hand side is that we've just changed the insulation level of the walls of this shoebox. And we have removed also the electronic equipment of this shoebox. And you see that, for example, if we take the blue curve, the performance of the cooling energy is reduced a lot. The shading is the same, the way the shading is used is exactly the same, only the building changes. And you see we almost divide by 2 the cooling energy only by changing the insulation level of the building. So this is just a kind of a warning for you to be very careful when you claim some energy saving thanks to shading. Of course, the shading, the glazing, the window is very important, but it's a complete building which is to be considered, and it's not sufficient to make one calculation to claim a performance. You need to have exactly the same parameter on the building to compare each product. So this is just another topic just for you to know that it's a kind of holistic approach. You must have to have a real assessment of the shading performance. Next slide. Okay, this is to present you some different calculations that I think have been done in Germany, just to present the difference of calculation of the GTOT value with different methods. And you see that for the same shading, and for the same glazing, you have glazing A, B, C, D. Only by changing the method of calculation, you have a difference in the results for the solar factor. So this is also to illustrate the fact that we will need to move to the detailed calculation method, which is the most accurate method, because there are some assumptions in the simplified method which leads to these differences when comparing exactly the same product with different methods. So be careful when claiming a value. It's also very important to specify which method has been used to calculate this value. Next slide. I think it's okay for me. No, the other way. Yes, I think it's Dev's turn now for ESDA or Zoe, I don't know.
Yes, good morning, everyone. I'm Dave Bush. I'm chair of the ESDA working group with a very good team that prepares the database. So if we can just run through, the simplified method has standard default glazing types, and the industry standard, as we know, is reference glass C. That's the value that appears on most manufacturers' data sheets. And the revised standard has a more accurate equivalent glazing, which Hervé said, which is reference default glazing F. Next slide, please. So for our high-performing especially reflective products, the detailed method shows a better and much more realistic outcome. So in using the detailed method, our concern is that unless we provide a guide to the industry, there will be different interpretations by marketing departments on the way it is presented. There are already issues with claims of compliance with the detailed method, so we are proposing a default window opening type to an agreed set of simulation parameters. In that way, we intend to minimize the inevitable confusion. Next slide, please. So the ESO proposal is that where the detailed method is shown, there should be a clear definition of conformity, and we're proposing a format to be agreed for use by the industry. To enable the calculation, the parameters for the room, other than the shading, are the window size, the elevation, the ventilation, the room size, the product type, and other energy flows. So they're an advanced building modeling calculation. So as Hervé says, the still simplified method will still be presented for fabrics, but the detailed is more appropriate for complete product. So we're intending that the calculations in ESDA, in the database, will be modeled using the EQUA modeling company. Sorry, you jumped ahead of me there, Bidan, sorry. Yeah, and on the slide there, you see the proposed model that we'll be using. That's a single room model. We're using EQUA because their modeling is based on the shading standards that we use. This has been the software that we have used for an automation study that Hervé will mention later, which is analysis of different shading control strategies in a single zone model, which is what this is. That will be determined later in the presentation. So the default window type is being determined from that study in conjunction with EQUA. We intend to create a verification certificate to conform that data calculated to the default window opening type. It will be validated as appropriate by ESO, and we're hoping to agree that a similar facility will be provided by our colleagues in ARC in America and BMAA in Australia. Sorry, next one, please. So just to confirm and clarify the purpose of ESDA, the database, it's a validation tool to confirm the accuracy of manufacturers' marketing claims. It is deliberately designed so that it is not a resource to search for best product, and that's essentially because there's no such thing. So next slide, please. So we have an issue with changes to another standard, that's EN 13125, which is not one over which the shading industry has any influence, but it has meant that the U-value calculations for shutters can be calculated, but those for blinds, the detail was omitted in the last revision. There is a calculation in the detailed method in EN 52022-3, and ESO has been working to adapt the ESDA database to provide that UTOT data, and by UTOT we mean the total energy lost through a building, to that requirement. It is logical then for us to calculate the GTOT value to the detailed method as well. We have the next slide, please. As we've shown, the detailed method is designed for advanced building specific calculations. That is, it depends on the type of blind as well as the curtain or fabric of the blind, whereas the simplified method is just the glass and the curtain. For that reason, there are going to be two sections on the ESDA database for the detailed method. It's the section for complete products that will be appropriate for detailed, and the section on the simplified method for fabrics alone. The detailed calculations previously been used, but up until now, manufacturers haven't applied complete product into the database. So that then means that either the data is shown on the complete product data sheets, or the fabric data sheets from fabric manufacturers would need to identify the product that the calculation applies to. But that doesn't mean that fabric manufacturers can't use the detailed data, just they need to identify the complete product that it's that their validation certificate shows that it applies to. Next slide. And as Hervé mentioned, for most products and materials, the values of the simplified method will be adequate, and it is intended eventually that it will be used for CE marking. Next slide. The other issue we have, the ESSO team have known for a long time that there have been problems, inaccuracies with building modelling software. The ability to compare the actual results from a recent case study to those of the building model of a leading international software tool highlighted the extent of the problem. The model predicted a maximum unshaded temperature of 27 degrees. In reality, it was 18 degrees more at 45 degrees. That's a massive, massive difference in calculation. Inadequate modelling programs have a major negative effect on the specification of our products in the building modelling process. Next slide. So in promoting the use of detailed methods to be used in building modelling, we will be devising a strategy to educate and advise both our own industry as well as the architectural and engineering professions. This will be assisted by the recent introduction into Europe of the NABERS modelling standard, which does post-occupancy evaluations, whereas most of the existing modelling, BREEAM or WELL, just model on the that just predict the outcomes. Nobody ever goes back and checks whether they're right. So NABERS and WELL will highlight the design errors in modelling, such as overlooking shading. So this will be a process of awareness and evolution. With the results from our automation study, it will also hopefully develop into behavioural change of how occupiers use blinds and shutters in their homes and offices. And I think I'm passing over to Zoe from here.
Good morning all. My name's Zoe de Gruyser, and I sit on the technical working committee for ESSO and also the training committee as well. So at the start of the presentation, Hervé mentioned that EN 14501 provides a way of categorizing performance data for early stage selection of materials, and they cover these various aspects. These are primarily split into two groups: visual comfort and thermal comfort. Next slide, please, Anne. So the standard, so there are 5 classes of performance, from 0, very little effect, to 4, very good effect. The purpose here is to provide a simple to understand chart so that a consumer can identify the performance that they need without having to understand the technical references like GTOP, UTOP, TVIS, and get them away from looking at all the percentage data. So these can be chosen based on the priorities of the consumer. Next slide, please, Anne. So, for example, if a consumer is looking for a product that has a very good darkening performance, they will also find that they will have a very good glare control performance, but have a poor daylight utilization class, which would suggest that when the blinds are closed, potentially more artificial light will be needed. And in some instances, this may be acceptable, for example, in bedrooms where little daylight is wanted, where in others, this would be unacceptable, for example, in offices and living areas. Therefore, the classes do not identify whether a product is necessarily good or bad. It's simply an easier way of categorizing products by their performance properties in relation to what consumers want and what salespeople sell their products based on. This way of viewing product data essentially places the differing properties of shading products on a sliding scale. ESSO proposes that a slider scale is useful for selecting the best product by balancing the different attributes of a shading product, so a consumer can get a more holistic overview of the impact a certain product will make and compare different product types. Next slide, please, Anne. ESSO believes that to gain more interest in promoting the benefits of shading, the depiction of our performance metrics needs to be easier for our customers to understand. The ESSO Simplified Data Initiative identifies how this can be done through using these new class categories that are in EN 14501, which makes the data more understandable. Essentially, it would mean we can move away from product specs like, and could you click please? Next slide. So product specs like this into data on the next slide, please, Anne, to something a bit more like this, where we can use the 0 to 4 classes and quickly see the difference between different product types. But if we want to get into more detail and see that the percentage values, we can also change the way this data looks. If you could click, Anne. So putting these on percentage scales can make it easier for consumers to understand. The benefits of shading for health, well-being and comfort, as well as the energy saving benefits, are becoming more important, and the need for understandable, accurate and validated data to demonstrate those benefits is becoming a lot more sought after. So it's important we try and keep it simple, so we're able to sell the right product and the right solution for to our consumers. And I think I'm now passing over to Hervé, who's going to go through some of the ongoing projects that ESSO is also working on.
Thank you, Zoe. So it's me again. I will just tell you about or give a really short overview on few projects that we are doing at the present time, and which I think will change a lot how shading is considered in the next months and years. First, the ICON project. It's a project that on which we work for maybe 3 years now, even more. To be in short, it started at the last R&T fair. It's a collaboration with different laboratories and associations all over the world. We are working with the Attachment Energy Rating Council in the US. We are working with the Berkeley laboratory in San Francisco. We are working with Fraunhofer Institute in Germany. We have also involved the Australian Association. And basically, this project is a way to promote shading through their characteristics and through the proper usage of the properties of shading. Dave presented you the ESDA database. I spoke a little bit about the fabric properties and the material properties, which are the real basis of the performance of a shading. The missing link, I would say, is to have these properties really considered into the modeling software, which allow the calculation of a building, whether it is for the heating or the cooling performance, or the operating performance, or the lighting performance as well. So in fact, there are a lot of different simulation software that can do this calculation on a building. And what we miss is to have the connection with the detailed properties of a shading, so that the real properties are used in this modeling system. The ICON project is to create the aim of this project is to create this link and to have a kind of open source link that will allow all modeling software to connect with database in which we can have solar shading properties. In practice, this means that, for example, a software like Terensis or Energy Plus or any other software that are used on the market could link to the ESDA database that Dave presented you, so that manufacturers will not have to reintegrate their data into the modeling software. So we are created a kind of web dedicated to the physical properties of shading, so that this software, which deals with a complete building, can link easily to the shading properties, and so that manufacturers or suppliers will only have to implement their data into one single database, and thanks to this link, this data will be available all over the world in all modeling software. So this is really a key project which has been funded by Fraunhofer Institute. I think it's very important to mention that Fraunhofer has been really the leading the leaders in this project, and it's very important that we can now switch. So as far as I know, the project is ready, and now we need to create the first test or practical test, so that we can verify that this project is really applicable on the field. The next project I would like to mention is about control strategies. In short, I was speaking about referencing to this modeling software which calculate the performance of a complete building. Most of this modeling software are considering shading, but most of the time they don't have any scenario to model how shading are used all over the year, and specifically when the shading are extended or retracted, and according to which criteria. There are some scenarios in some modeling software, but most of the time they are not verified, and they are not how to say, they have not been tested to show how they behave. So what we started more than 1 year ago with a small group in the technical committee with Maria, Zoe, and Jean-Paul Clément, we have, thanks to the different references we have found in scientific studies which have been carried out on shading, mainly in the US, we have created some conventional control strategies of shading, which consider different assumptions. You see on the screen, I will be very, very quick, I will not detail, but we have defined 3 main usage of shading. First is manual operation, so a crank handle or cord. The second is a motorized operation, whether the product is operated by remote control or a switch. And the third one is a complete automated operation. And for each of these operation mode, we have defined conventions to define when the shading is used, is extended, and how it is used. To make it short, we considered in these control strategies the season, the external weather condition. We consider also the internal temperature in the room. We consider also whether it is day or night, of course. And we consider also the radiation facing the facade. And when we combine all these parameters, we have some scenarios which define when the blind will be extended and how much the blind will be extended. And our target, if you can move to next slide, please, Anne. Our target is to have this kind of curve. For example, on the left-hand side, you see that you have the manual, so motorized mode and auto mode, and here we are set on the left-hand side the cooling energy on a building, and you see that when you change the mode on the shading, you improve or you reduce the cooling energy needed in this building. And this is exactly what was our target, to define strategies which improve the performance of the usage of shading. On the right-hand side, you have the heating energy. you see that it's difficult to have a huge differences into the different mode for different reasons. I will not detail, but when we have a glazing which is performance, then the improvement of the shading is reduced. But you see that, for example, the single dot you have, the square you have, is a solar controlled glazing. So we compare also a clear glazing with a shading with a solar controlled glazing, and you see that thanks to a clear glazing with a shading, we can optimize the energy demand. So we are much below the solar controlled glazing. So I will not detail this more, but just for you to know that I think also this study will be a big step for the industry. The next step will be to have these control strategies implemented into an ISO standard. There is an ISO standard going on. The first project will be sent to inquiry next week. So we have been in a hurry to develop these strategies, but being in an ISO standard, this strategy will become a kind of references for building simulation, and this is very important. It will be then possible that each modeling system could use these control strategies, and we will see the improvement of the performance thanks to that. I will not detail this more. I can spend 2 hours on that, so it's not really the target. But just for you to know it's going on, and you will have much more information probably in the next months, well, in the coming months, when the study will be completed and when it will be implemented into the ISO standards.
Okay, so thank you, Hervé and Anne and Maria. So you see that we are really stepping up the solar shading industry towards an essential building technology. As I said before, the Green Deal and the climate change is pushing the European Commission for finding solutions, and the politicians are looking desperately for solutions to have resilient solutions. And I can say that all the work which has been done has been a tremendous work, and we have done a lot of studies, and great developments are there, because we are now also going to integrate in a better way the control strategies. All of these elements will be part of also a very important communication project, which we decided 2 years ago, more than 2 years ago now, at the Business Summit of ESSO, the first business summit which we had. And we decided in that business summit, together with our sponsors, to start a very important communication project with a company which is called Navigant, and that's a guidehouse company which has a very high recognition with the European Commission, and which has a very high recognition also with the politicians. So it's more a study which will allow us to communicate in a better way that solar shading is essential and is an essential building technology and is a resilient natural solution to beat the climate change in a natural way. They hold building statistics for the whole of Europe, and the question is where will Europe be in 2030 or 2050 if shading is recognized or not? What would be the impact of that? And it will be a very highly valuable report, which is now also going to integrate this new ISO standard and control strategies, because that is one of the points which took more time than we expected. But anyway, it will be a big step forwards if we conclude this study, this project in the last part of this year. So that will be the deadline. Next slide, please. On the other hand, we have already created a smart solar shading website, as you see it on the slide here, smartsolarshading.com, which is already existing in different languages, and where we explain in a very simple way all the advantages of smart solar shading for both either the residential part, which you have at the left, or the project part, which is a little bit more complex, but which is also explained in a very simple way. So even an end consumer who wants to know more about smart solar shading is already able to look at it and understand in a few clicks all the advantages of solar shading. In order to make our industry ready for it, and you can click Anne, we also created a very interesting training program for which we already have, and correct me if I'm wrong, Anne, but I think we have already about 350 smart solar shading advisors, which are in fact professionals of our industry, which already have obtained the certificate of Smart Solar Shading Advisor. We also are now developing the expert level. Expert level is more for bigger projects and not residential projects, but bigger projects where people want to know more in detail everything that we discussed before. The advisor, on top of that, the advisor level should soon be online and making people able to follow this course online. So that's a good development as well, because over the last year, as we all know, the digital developments have been enormous, and we have adapted our training program to that as well. But of course, end of the year, I think the next trainings in different countries will be going on as well. Okay, please click Anne. So this is it for us today. I hope that you had some good coffee, and maybe for the marketing people, what we discussed today was a little bit complex. It is not complex. It is exactly what Zoe explained. We need to make it simple for our business users, but we need to make it simple for our end consumers as well to follow what is going on with our essential technology and how this is developing, going from a product in which it was in the past to a real solution for beating climate change and a real essential building solution. So that is where we are heading for, and that's why we are making our industry and also architects and developers understand more about all the advantages of our great technology. So now I think we are coming to the question and answers, if we can give them. Anne, have you followed it?
Yeah, just hello everybody. Just I see in the chat box a number of questions indeed. The first question is there a database of typical cutoff angles that we can reference to?
Well, to my knowledge, there is no such database. Also for our industry, with textile solar shading, it is a totally new concept. So the measurement is also new to us. So if it could be in a database, I think the ESA database would be the ideal one. But of course, people have to become aware that this is a possibility, and then they have to see if their fabrics are indeed something that could have this low cutoff angle. Because of course, if you are sure, yes, I have a thin regular fabric, and the cutoff angle you think will be higher than 65 degrees, then of course it would not be efficient to have it tested. So the standard EN 14500 now describes how to measure it for fabrics. And it also states that if it's only to see if you have this extra glare class, then they stop measuring when it's above 65 degrees, because then it's not it's not qualified, so then they put it aside. So it's a bit, yeah, I think it's only relevant for materials that can have this this cutoff angle, and I think it will be more like new fabrics that will be developed to obtain this than for existing ones. So perhaps in the future.
Okay, thank you. For the opacitive performance, I got a number of questions. The first, what are the recommendations about which device to use to create such a minimum incident light? Maria.
Well, yes, as the standard says, it's intended to simulate the light, for example, that passes under a door. So if you have a room you can use for this purpose, I would just recommend to use a lux meter with a precision enough to measure 2 millilux. And then let some light through under a door or through a gap and measure this level where the sample is to be placed. The color rendering index for this light is not very strict, so you can use a normal artificial light in a room next to this light-tight environment.
Okay. And another question, opacity performance, how is the reference material to qualify the observer selected?
Well, this reference material, I think this question was from Helen Rose Wilson from Fraunhofer. So I think you can fabricate your own material, because if you have access to use a photon counter, it is a material that for any level of light, if it's higher than 100 lux, it allows 100 photons per second. So you can use a material that can allow some light through it, and just use different levels of incident light and measure when you find these 100 photons. So you can fabricate it, or in some laboratories have already done it. So if you are in touch with other laboratories, perhaps they already have it.
Okay. Then another question, why not put more importance on the double protection outside and inside? Of course, it's a question for everybody, but Hervé, I think.
It's not that we don't give an importance on that. I didn't mention, but in our control strategy study, we will have a strategy for this kind of situation when we have both internal and external shading. So internal being more for glare and external being for solar protection. So this is something we will address. But of course, the idea of these two products is not that they are used at the same time. They just have different purposes and have different aims. So we will address this situation. And I think we will prove that this is the best situation for comfort and for performance. Okay,
good. Another general question: will these handouts become available? Well, I think so, because we are recording this the webinar. We will also present some documents. That will become available just to everybody who has registered for this seminar. And the recording will be also available on YouTube. And next, can the details of those scenarios be found anywhere?
Well, for now, we are just working on the technical committee on that. They will be in the ISO standard, or if you are interested, you can also join the technical committee. We have a meeting every 3 months, and I report in detail these control strategies during this technical committee. So if you want to have more information, you just have to apply to the technical committee, and I will be very happy to share this information. As I mentioned, I don't remember if I mentioned that, but all the values we have defined in these control strategies, this is not something we have invented. They are all referenced from scientific studies. So it's a way to gather all information we have found in different studies in one single strategy. So just to answer quickly, they will be publicly available when they will be integrated into the ISO standard, so in a few weeks. And if you want to know more, join the technical committee.
Okay. Then on the ICON project, how can we make sure that all simulation softwares use unique products database? Maybe something for Dave. Dave, you have to unmute. Yeah.
Yeah, obviously it's a very complex arrangement that we're coming up with, and the idea is that the different databases, which essentially is the Australian, the American, and the European one, will be able to interlink. And in promoting them, we obviously will highlight that the information on those is the accurate information to use. It's validated data, whichever database you use. That's a longer term objective, and it depends on the industry getting behind it to promote it and taking part in the databases, which we could have a lot more involvement of companies in the ESDA database.
Okay, these new standards, 14,500 and 501, are these standards by now formally proven? RV, yes, they are published.
Yes, they are published. They are published, so they are available. You can buy them. Yes, they are available and approved and voted.
Is there an overview of institutes already able or allowed to work with these new test methods?
Well, yes, there are. First, there are the labs which contributed to this standard. So Fraunhofer in Germany, ITV in Germany, CSTC in Belgium, mainly. I hope I do not forget any other lab. So I think there are the three main laboratories which are able to do these measurements. Maybe there are some others. I don't know some others, but maybe in some countries there are some other possibilities. But at least the three labs can do the measurements.
And also, just to add on that, and Dave will confirm this, with ESDA, we are validating with different manufacturers in a neutral way. We are validating the data. So either it are the official laboratories which are certified to do this testing, or in ESDA we integrate the data, the spectral data which we discussed before. We integrate it after a complete validation process. So this is a very, very nice way of making our industry work together. And also, I'm also very happy that we can share this webinar, and that we see that this community is really starting to pick it up, and that we start talking as a community and working together. As Dave said before, what we now need is not only fabric manufacturers to integrate the ESDA, but also system manufacturers to integrate into the ESDA database. As we have these new standards, it becomes possible for manufacturers of systems, of blinds, of internal, external blinds, but also roller shutters, to integrate into the ESDA database and use it for their communication to architects. So I would warmly welcome them to become part of the ESDA, and we are open for that. So it's the complete system is well oiled and well used and well developed over the last 10 years. Now with the integrating the U values and the detailed GTOT values, it really becomes a real tool that you should use as an industry and as a professional. So warm welcome to everyone to become part of this.
Okay, and then just a final, let's say, comment from our ESO marketing chair, who had to leave now the chat box. She said, please also join our European Solar Shading LinkedIn page, because we are announcing a lot of activities and news on this LinkedIn page. So that's all in the chat box. So I give the last word to Peter just to close the meeting.
Okay, so thanks Anne and all the participants and all the invited people who wanted to know more about solar shading, to know more about how our industry is developing. We are personally, I'm really very happy to see that we are now moving to the next step. We created ESSO in 2004. We are almost 20 years later. We have done a lot of studies, a lot of work. Technical committee has done a great job. Now we have also created a marketing committee and an advocacy committee to communicate more about all the advantages of our technology. And I'm really very glad to see that we have great tailwinds with the Green Deal, with the climate change, with the youth for this longing for natural solutions. We have everything in our hands to do it. So please use it and make it happen and communicate, because that's really we are the ones that make this happen. And I'm really glad to share this with you and to be able to do this together with our fantastic community. So I would really like to thank you for being part of this, and I can tell you it will not be the last webinar. So it's a great solution, digital solutions, to be able to communicate in a better way. So thank you very much, all of you, and have a great day and a lot of sun.
Okay. Thank you all. Bye.
Bye.